All right, welcome to The Explainer. Today, we are diving deep into something that's frankly one of the biggest security puzzles out there right now, hacking AI. I mean, think about it. AI is running more and more of our world, so the real question isn't if it can be hacked anymore, it's how.
This isn't science fiction anymore. AI is literally the invisible engine behind so much of our daily lives. It's making huge decisions in our hospitals, our banks, our cars. It is quite literally everywhere.
So, as we're handing over the keys to all these incredibly powerful systems, you gotta ask, right? Is any of this actually secure?
And the answer? Well, it's way more complicated than you might think. See, securing AI isn't just about patching a bug like you would in a normal app. We are dealing with a whole new class of vulnerabilities. These things don't just crash the system, they trick it.
So that brings us to our first big idea, AI's new attack surface. The reason these vulnerabilities are so different is because AI itself creates this totally unique and constantly changing landscape for cyber threats. It's a whole new frontier.
Okay, so here's the core of it. Think about old school software. It's deterministic. You give it an input, it follows a strict set of rules, and it gives you a predictable output. Simple. But AI, that's probabilistic. It learns, it adapts, it makes guesses based on tons of data and statistics. And that very adaptability, that's its superpower, but it's also its biggest weakness.
And listen, this isn't just some theory we're talking about. AI is already out there, right now, in some really critical places. We're talking customer service chatbots, fraud detection in banks, even medical imaging in hospitals. And because they're so important, every single one of these is now a juicy, high-value target for attackers who know exactly how to exploit that probabilistic nature we just talked about. Which leads us to the next big problem. Because these AI systems are a whole different beast, our old security playbook, well, it's just not working anymore. It's failing. Yeah, just look at this comparison. It really tells the whole story. With traditional pen testing, you're looking for bugs in the code, right? But with AI, you're hunting for something completely different, flaws in the model's logic. And you have to do it across the entire machine learning lifecycle. The goal isn't to crash the program anymore. The goal is to fool it. And this quote just nails it. Traditional security controls often prove inadequate against attacks that target the inherent probabilistic nature, complex data dependencies, and nuanced decision-making processes of machine learning models. I mean, that's the whole ballgame right there. Our old tools were built for a world of predictable code, not for a world of learning, adapting machines. We need a new approach, plain and simple. Okay, so let's get into the nitty-gritty. It's time to meet the new villains of the story, these unseen digital threats that are custom-built to exploit AI. Broadly speaking, there are three major types of attacks you need to know about. First, you've got prompt injection, which basically uses malicious text to trick language models. Then there's adversarial perturbations. These are tiny, almost invisible changes to images or data that totally fool vision models. And finally, you have data poisoning, which is as nasty as it sounds. It corrupts the very data the AI is trying to learn. So let's look at prompt injection in action. Check out this real-world example. What's wild is that an attacker doesn't need to write a single line of code. They just have to be clever with their words, asking the right malicious question. A prompt just like this one can jailbreak a language model, basically tricking it into completely ignoring its own safety protocols. Then you've got these adversarial attacks. And honestly, this is where things get kind of scary. Imagine a stop sign. An attacker makes a few tiny changes to the pixels, changes you and I would never even notice. But to the AI in a self-driving car, it doesn't just get confused. It confidently, 100% believes it's seeing a speed limit 45 sign. You can see how that could go wrong fast. And maybe the sneakiest threat of all is data poisoning. This is a slow burn attack. It's stealthy. It corrupts the AI's brain little by little over time. And here's what makes it so dangerous. That number right there. On average, it takes a staggering 47 days just to realize your AI has been poisoned. By then, who knows what damage has been done? Okay, I know it all sounds pretty daunting, right? But it's not all doom and gloom. There is hope. A new generation of defenders is stepping up, and they're learning how to fight back with brand new specialized strategies and tools.
When an AI system gets breached, the response plan is totally different. You can't just patch a server and call it a day. No, defenders have to first detect really weird model behavior, then dive deep to analyze the model's internal logic, contain the problem to stop the bleeding, and then, this is the big one, often the only way to recover is to completely retrain the entire model from scratch on clean data. And to do all that, defenders have a whole new arsenal of tools. Many of them are open source, like the Adversarial Robustness Toolbox, or ART, and Clever Hans. These are frameworks that let security teams basically simulate all these crazy attacks we've been talking about so they can test how tough their models are before they're out in the wild. So, who's on the front line of this new battle? Well, you've got the AI red teams. The easiest way to think of them is as ethical hackers, but specifically for AI. Their entire job is to throw everything they've got at these systems. Prompt injection, model theft, you name it. They find the holes before the bad guys do. And if the red team is the offense, the blue team is the defense. They're the ones defending the fortress. These are the architects who build and maintain the AI's defenses. They're setting up real-time monitoring to spot attacks live, and they're the ones with the forensic tools to figure out exactly how a model got compromised after the fact. But here's where the real magic happens: purple teaming. This is where, instead of working in silos, the red team and the blue team, the attackers and the defenders, they team up. They run these live, collaborative exercises, which creates this incredibly powerful and fast feedback loop. The defense gets stronger, way faster, against the kinds of threats they'll actually see.
All right, so how do we wrap all of this up? How do we build AI that can actually withstand these attacks? It really boils down to a new set of principles for building resilient AI.
And you know what? The results are real. You can actually see the impact. After doing this kind of specialized AI pen testing, organizations are finding they can cover up to 85% of their known attack paths. Look, it's not about achieving some mythical perfect security. That doesn't exist. It's about being smart and dramatically, measurably reducing your risk. So what are the big takeaways here? If you remember just a few things, make it these. First, you absolutely need a specialized approach for AI security. The old ways are broken. Second, security can't be bolted on at the end. It has to be part of the entire process from day one. And finally, and maybe this is the most important one, the security pros and the AI developers have to start talking to each other and working together. No more silos. And all of this leaves us with one final, pretty heavy question to think about. As we are all racing to build this incredible future powered by AI, who's building its defenses? The answer to that question is going to define just how safe and trustworthy this new world we're creating will actually be. Thanks for joining me on The Explainer.